So what is the purpose of presenting all of this? Well, first of all, to emphasize that we did not just think of this overnight. We did not just decide, well, let's strap an accelerometer on the rump and put one on the head and call it done. Our approach to developing this equipment was targeted. It was directed to one purpose and one purpose only, and that is to develop a lameness tool that equine practitioners could use. We did not just take existing technology and try to pigeonhole it into the task of measuring lameness in horses. We developed much of our own technology. That is why the lameness locator sensors are the way they are, the size that they are, have the transmission range that they have a battery charge that lasts for as long as needed for an equine veterinarian, etc. Everything about lameness locator is that way because it works best that way for the equine practitioner. We also wanted to emphasize that this equipment was developed by a collaboration between actively practicing equine veterinarians and teams of computer, mechanical, and electronics engineers. It was not just developed by engineers with a side interest in horses or by equine veterinarians dabbling in hobby electronics. It took the experience and skill of both. Here is the current makeup of lameness locator and our current Generation 2 sensors. The Generation 2 sensors are smaller and more robust. There are still 3 sensors, an accelerometer for the head and pelvis, and a gyroscope for the right forelimb. We now have these iconic labels to help the user remember proper orientation when placed on the horse. They are attached as before, the head sensor to a felt head bumper worn by the horse, the right forelimb sensor in a pastern wrap, and the pelvic accelerometer is snapped to a short strip of 3M dual lock tape, and sometimes we use additional tape to secure. No clipping or gluing, which owners do not like, is required. Data is collected live. The first channel is head acceleration, the second right forelimb angular velocity, and the third vertical pelvic acceleration. We use a top-of-the-line hardened tablet computer from Motion Computing with state-of-the-art direct sunlight viewing capability. Input is with a pen stylus. The receiver is a small plug-and-play USB Bluetooth Class 1 device. The Generation 2 sensors are also more robust. To prevent mechanical failure, the sensors are turned on and off with a small magnet, and the battery charging mechanism is improved. There's no openings in the sensor housing to make the sensors more water resistant. Each sensor weighs about 30 grams, which is small enough such that it does not encumber or alter torso movement. The sensors are a little bit smaller, 3.5 by 3.4 by 2 centimeters. Range of live data transmission is about 100 meters, although in some environments it is longer. It requires less than 3 minutes, even at a leisurely pace, to instrument the horse. It is easy to use, and once one becomes familiar with working through the software, will not or should not interfere or obstruct the normal lameness evaluation. Some current users just have their technicians collect and analyze the data while they're performing the normal lameness evaluations. They then just look over and view and interpret the results. However, you do not have to do it this way. It is easy enough to use even if you have no help. I have used it in some horses in research studies, like late at night during a timed trial when I didn't have anybody to help me trot the horse, so I would just set up the equipment, select start, grab the horse, trot back and forth, then stop, hit stop on the computer. So you could do it by yourself if you really had to. I've also collected and analyzed data while lunging the horse without assistance.